Guys, question.
Yeah.
I just saw here we have 2 attempts to the quiz. Was always like that, or was just this one?
That was always like that.
Really? I never take twice. I always take just the one that we take together because I didn't know.
Well, we usually do pretty well together. We usually get high scores.
Like when we don't get 100%, we can take again. But I didn't know that.
Huh?
I guess. So we're supposed to download or use the 2 Excel files, the chapter 12 data A1 and chapter 12 data B1, right?
What?
Oh, the quiz is providing 2 Excel sheets.
Yeah.
Oh, yes. I'm opening right now. For what? To fry?
Because we can use less oil.
Yeah, but it's less space too. Okay. Sorry, guys.
So you're good.
Okay. Should we start?
Yep.
So providing us information for the next questions. The after standard deviation. No.
Just because you're sticking.
Okay. This first one is kind of easy. So first you need to calculate the t-value, right?
Yeah.
Let me open the Applet. Which one of the Applets are we using? The second one or the first one?
The second one. It says on the quiz. There's a t distribution applet they link for on the quiz.
The Irish one.
Yep.
Okay.
All right. Cool. So t-value. Don't we need?
So we don't know the.
He's giving the difference. 2.2.
Yeah.
So it used to be 2.2 divided by the 3.3 by 9?
Divided by the square root of 9, yeah.
Okay.
Oh. I got 2, guys.
You got 2?
Uh-huh.
Yeah, it's up, guys. Oh, no, that's okay.
Sorry, how much did you get?
Oh.
Do you want to be more noise? Because I think that's not enough. Come on, louder. You could do better than that. You're laughing. You could do better.
Julie, did you get 2 as well?
Hold on.
What'd you do to figure it out?
I got 2.
What'd you do to figure it out?
I used the formula. Oh, wait. 2 is my t-value. Now I need to put in the Applet, right?
Maybe.
So what I did the t-value formula. So it's difference minus 0 dividing by standard deviation dividing by squared root of sample size. And then the number that I got, I put in the Applet thingy. I got 2. And now, like, my area is 0.139. I just want to check one thing.
I think the answer might be 2, I think. Because I think the test statistic is the t-value.
Oh, it's the t-value?
I think so. If I
It's
remember
two.
correctly.
Yeah, you're right. It's asking for the test statistic. So I got 2. What did you get?
I got 2 as well.
What about you, Julia?
So I divided 2.2 divided by 3.3 divided by the square root of 9.
Of 9. Yeah, but one thing is what I noticed when I do the math. If I put direct in this order, the numbers in the calculator, it always gives me a different number. So as I told Paul last week, the way that I do first squared root, then I do standard deviation dividing by what I got, then I do the d minus 0 dividing for the answer that I got. Did it make sense?
Okay.
I do like the squared root first, and then I keep going up.
So it's divided by.
I was at a scientific calculator.
Yeah, huh? That was good.
Did you get 2?
No.
Here.
So
Can
I
you see? So first we do squared of 9. Then let me see the standard deviation. Then we do
3.3.
3.3. Where's dividing? Dividing by answer. Okay, that's what we got. And then we do 2.2 dividing by answer. And then we got 2. Can you see?
2.2.
Yeah, because 2.2 is our difference.
Okay.
It's the d value.
I literally just did it.
Okay.
Make sense?
Okay. I go by 2.2.
Sounds good. Okay. So, number 4.
Yep.
The probability of obtaining a test statistic greater than Jordan's test statistic is 0.403. Use this probability to determine the p-value for Jordan's hypothesis test.
Do we plug that into the, plug 0.0403 into the output?
What?
Yeah, I think so.
Just put the 0.0403 in the output?
I think so, yeah.
Into the top, I think, right?
Because it's kind of the percentile, right? Makes sense.
Yeah, it's a theory out of probability.
And then we select right, left, or?
That's what I need to figure out. So the problem.
So the 0.03.
Oh, he's saying greater, so I think it's middle and right. Because he's saying greater, right?
Yeah. Yeah, it sounds right.
Yeah. So it's 95, so 96, 0.96. No, sorry, 0.960.
So you write the t-value on the test in the bottom, don't you? Like, don't you supposed to write the t.0403?
I think that's the probability. The t-value is its own thing, and then I think because it says probability, you put it in the top.
When I put this value on the top, it doesn't let me select the middle area, just the right one. I don't know why.
That's weird. It's letting me do the middle.
Wait, are we using the Irish one or the other one?
The Irish one.
Yeah, that's what I'm using.
So you
Yeah.
put the, is the degrees of freedom, like, do we have to change that too?
Hey, Paul, can you show us our screen, please?
Yes.
Do we need to change the degrees of freedom to 9 or 8?
I don't know. I'm kind of confused in this one. Hey, Sydney, do you want to turn on the beans? Because it will take a while to get ready. And I think it needs more water.
No, I think degrees of freedom may stay the same because I don't know how to figure out the degrees of freedom.
Thank you for calling. Yeah.
So the test statistic is the top, the area?
No, he's asking for the probability.
Yes. So I'm asked my question. So do you suppose to put the test statistic, the 0.0403 on the top?
I don't think he's on the top because he's saying the test statistic, and the test statistic is the same as z-score. So
it's on the bottom,
0.04 goes in the T
right?
field.
That's what I think.
And then on the top will be our answer.
Do we change the degrees? Like, because automatically had 3, but we're like, our sample is 9, and you always like subtract 1. So should we put 8 on there too? Do we change that number?
It's not letting me select the middle field again. I don't know why.
I don't know what to change the degrees of freedom to.
Paul, do you want to show us your screen? I think it will make more sense.
But did we change we put 0.043 on the top or on the bottom?
I think it's on the bottom because he's saying the test statistic is 0.403. And then he wants to know the probability. So the probability is the top. The test statistic is the bottom.
Yeah, I agree.
That's what I think. 0.0403 should go on top because he's saying that the probability of getting a test statistic greater than Jordan's is 4%. Does that make sense? So it's saying that 0.04 is 4%. So it's saying that there's a 4%
gotcha.
that it'll be greater than the test statistic. So 0.0403 should go on top.
Yeah, makes sense.
And then you should be able to highlight whatever you need.
It still doesn't let me highlight the middle one. Like when I type the value, it goes just to the right side. I guess it's just the right side then.
No, you put the 0.403 in the top, it becomes bigger, so you'll be able to have more space to.
Can you see my screen? You should be able to highlight it.
Yeah, but when we highlight, the value changes.
True. So I guess it would be 2.597 then? Is that what we think?
So how about the degrees of freedom? Do we change that number? It has 3.
What would we change it to?
Because it's usually 1 minus the sample size. So we have the sample size 9, and the degrees of freedom is usually 1 less, so it should be 8.
Okay, yeah, let's change 3.
I think our answer will be the number in the bottom.
Yeah, but if we change
Yeah.
the degrees of freedom, it changes the data.
Yeah, change
Yeah,
the
'cause
freedom to 8.
it's the same as p-value, and he's asking for p-value, so I think it's 2.597, the
Yeah,
answer.
but Camilla, you need to change the degrees of freedom at the top to 8.
Oh, gotcha. But why?
Because
In the
Julia said it right. What did you say,
Yeah,
Julia?
so like usually the degree of values is one less the sample size. So we have the sample size of 9, so it's always one less. The formula is always one less, so it should be 8
Yeah.
because it when that changed to 8, the number changes. Any number that we put.
Wait, guys, I'm gonna move because I cannot hear you. No, it's not your fault. Okay, I'm gonna move. Where? I don't know. Okay, sorry, Julia. Can you say again one more time?
So there is a formula to get the degrees of freedom, and we're supposed to subtract 1 to the sample size. So we have in this case sample size is 9. So we subtract 1, the degree of freedom, the degrees of freedom is 8. Should be 8.
Wait, he's not asking for a degree of freedom, is he?
Well, the applets had a number 3, and so we leave the 3. I guess it's just because that's the last number that it was there, that it will affect our answer. So I believe that we need to change that too.
Okay. Got it. So
then we highlight the middle and the right.
I think so.
So the question is the probability of 0.0043. Use the
So we got 2, right?
use this probability to determine the p-value.
We got number. Did you get 2, Paul?
For the for what, number 4?
Yes.
I got, well, yeah, 2, yeah. But doesn't it want 3 decimals? So you just put 1.999.
But
Yeah.
if we round, it's 2, isn't it?
Yeah, but it says it wants 3 decimals, right?
The answer, yeah, it wants 3 decimal.
Yes, and it only gives you 1.999. So I think that's,
Yeah,
Okay.
I think.
yeah, I agree.
Okay.
Now we know that we can take it again.
Yeah, real.
Okay.
So
Number.
here's the data.
Now we're gonna need the thinking.
Okay, so it says so we have to first make the difference, right?
Yeah,
To the
and I
formula.
found 31.025, if you guys figured that out.
What?
Wait, are you doing already number 5?
Yeah, I'm just trying to find the difference of the mean and the difference in the standard deviation.
Okay, let me do it.
Okay, so
Hello.
so let me know when you have it so I can compare.
Yeah, so what'd you get for the
Work.
mean?
For the T, I got 0.407.
Guys.
Yeah.
Okay.
What'd you get for the difference?
I didn't even get the difference yet.
Oh, okay.
What'd you get for the difference, Julia?
So T is, I mean, DF, right? DF 19.
Okay, 1 second. The difference between the means is 19?
Yeah. Wait.
I got 31. So yeah.
Oh,
Yeah, I
wait,
got 31 point.
Yeah, I'm sorry. I thought you said DF difference. Never mind. The mean is 31.025.
Okay, and what'd you get for the standard deviation?
Standard deviation 341.157.
Standard deviation. How'd you find that one?
Am I giving you like weird numbers?
The mean was fine. Just I don't know how to find the standard deviation.
Well, I just plugged the numbers into the the Excel sheet that he was using on the
Okay.
on the video that he was talking about.
Okay.
Guys, I don't know why mine is not working. I cannot even do the difference.
So I just put the formula, so that.
Can you see your screen?
So I don't know how to work that one. I haven't been able to know how to share screen. Let me see.
You click the green thing with the arrow.
Let me see.
In the left of your Hangout screen.
Am I sharing it?
Not yet. You have to click. Yeah, now you're sharing.
So this is group 1, and this is group 2. I just make the, like the formula A2 minus B2, copy all the way, and then copy it again, but just into numbers, like general, so it doesn't copy the formula. So I can copy it into the other test, into the other Excel sheet, like this one. Do you see this one now? That's where I got, the mean and the t-value, the standard deviation.
Okay, can I try just a second?
Mm-hmm.
Sorry,
So
guys.
this one, I'm not sure if we need to, if it is matter, because it doesn't tell the confidence level that we need to have.
Isn't the standard deviation, isn't it? So you do the standard deviation for one of the columns and the standard deviation of the other column, and then you subtract the two? Isn't that how you do it?
I thought it was just one minus the other one.
Yeah, exactly.
Yeah.
Let me show you what I did.
Uh-huh.
This is a hard one. Let me show you what I did. Sure. Okay, so what I did over here is I just did the standard deviation for this column and the standard deviation for this column, and then I subtracted them, and I got this.
Well, this one I input it into this one, the Excel sheet that they just gave us. And
Yeah, doesn't I feel like 341 is really high though, isn't it?
Hey guys,
yeah.
we do the mean from the difference or from one of the columns?
From the difference.
It's because they are such a great, like, big numbers. It goes like, you know, I have like 200. Like the difference are like so like extreme. You know, like there are 32, and then there are like 300. I feel that the numbers are so like randomly extreme.
Mhm. This is tough. Freak.
Yes, we are. It's very. So.
Okay, yeah, let's do that. So it's 341. So what was the test statistic you got?
Oh, guys, wait.
Well, you're talking to her? Oh my gosh.
Oh, my. My Excel is not working very well. How much did you get? Do you guys get for the mean?
Still trying to figure that out.
You know, there is another
For
one.
the mean, I got 31.025.
Me too.
Good.
It's 31.025. Yeah. So the
For
standard deviation.
standard deviation, 341.157.
Yeah, 341. Yeah, it's just so weird number, right? 341.157. That's a weird standard deviation. Like Pulsar, like it's too big.
It feels like it's cheap, but I mean, I feel like that chart's been right so far. So.
I think we should use that one.
I think we can use that. Why wouldn't we use that?
Yeah, because we didn't even put the numbers. We just copy and paste.
Yeah, I agree. I think that's fine.
Yeah.
So now we just need to do the formula, right?
Yeah.
What is our sample number? Is
So then
20?
Yeah.
So number 5, the statistic test. So we just do the same formula, right?
Yeah. What do you multiply it by? Oh my goodness.
Okay, I got 0.407.
Yep.
Two.
Thing.
Yeah.
All right. I think we got that one. Oh my goodness. Okay, number 6. So now we plug that into the applet, right?
So the p-value is 0.688. What do you think?
Let's see, I'm trying to find that.
I'm just getting the numbers from the Excel sheet.
Yeah, that's good. What was?
I got 0.688.
I don't understand.
0.669.
The p-value, I just got it from the Excel. It's giving me that
Because our test statistic is the same as p-value, isn't it?
No. I think the test statistic is the t-score, isn't it?
Yes.
So that was number 6. So the p-value was number 6, right? And now it's asking us for weight, number 5. The t-value was number 5, and now it's p-value number 6.
So the chart says, okay.
Okay, I don't understand. I put the 0.407 as our t-value, and then we select the right and the left side, right?
Yes, that's correct.
But then I got 0.964.
I got 0.688.
Me
Let me see your screen.
Yes.
Mila, sorry.
Ah. Okay.
Oh, it's 0.407.
Oh, that's right.
There you go. And then change the degree of freedom to 19.
Did you change?
There you go. That's it.
Oh, that's right.
Aha!
To pay more attention.
Ah!
You got infinity and beyond.
0.669.
Yes.
Okay, so what is the correct decision based on that evidence? It's greater than.
So it's 10? How much
so
was the difference?
we failed to
0.10.
check.
So it's greater, our alternative hypothesis, right?
Yeah, if it's greater, we fail to reject.
Yeah. All right, moving along.
Wait. So number 7 says fail to reject.
Yeah, fail to reject. Suppose your alternative hypothesis is instead, what is the correct decision based on this evidence? Okay, if the mean was bigger than 0, it still would be greater, right?
Down is so it's, I think they're changing now the opposite hypothesis.
I think it's the, okay, guys, what do you think? I think it's the third option. We have sufficient evidence that the mean of the differences is greater than 0.
Yes, I think so. I'd say that's right. Because we have a bigger number.
Yeah.
0. All right.
Yeah. Number 3.
Good. Now we got to open up another Excel sheet.
Let's do the
Gonna do the
difference.
Okay, here we go. Hold on. Use the data file to answer the next 8 questions. Perform a paired samples of 2 tests in SPSS. Be sure that the test does group 1 minus group 2. This data comes from no the null hypothesis is that, and the level of significance is 0.01. Which is greater? N or the difference? You gotta find the mean.
So N is greater, right?
That's what I'm trying to figure out.
Because DF is N minus 1. No, no. Don't listen to me. I'm wrong.
The answer.
So n is what? N is the
N
number
is
of people.
22, right?
Yeah.
And the
And then the
T
difference is 11.9.
Yeah, so N is bigger.
It is bigger. There you go. No, you're right. You're right. Yeah. So we gotta find the t-value then.
Yep.
So wait, so we agree on the 9 is DF is greater?
N is greater.
Okay. DF. Oh yeah, sorry, yes. So and the p-value, I got 0.001.
How much did you guys got for standard deviation?
15.003.
Okay. I'm doing the t-value just a second.
Okay, I'll do it just in case.
Okay, for t-value, I got 0.797.
Really? Huh.
For t-value, not for p-value.
Oh, t-value 3.737.
No, 0.t97. That's my t-value. Now I'm gonna find the p-value.
Okay.
I got different.
Yeah, so my p-value is 0.434. Is that what you got, Julia?
No, I got 0.001.
Question. So how did you find the t-value again? So did you do?
I just plugged the number in the Excel sheet.
Yeah.
I can show you my screen. Yeah,
I use the formula and then I put in the approach.
so I
Well,
just use
you
this.
do Camilla 15.003 divided by the square root of 22.
Yes.
And then what do you multiply it by?
I didn't multiply because I used the value, the formula x minus, no, I used the formula d minus 0 dividing per standard deviation dividing per square root of n. Is that wrong?
No, that's right. I just couldn't remember the formula.
So I use this formula, and then for t value, I got 0.797. Then I changed the degrees of freedom for 21. And then I got the p-value 0.434.
That sounds right to me. You got something different, Camilla? Julia?
Yeah, I just like for the you know the p-value that it shows in here is different.
That's confusing. That's really confusing. Because I got 0.434 as well.
How much do you find?
I got 0.434. You got 0.001.
I got 0.001.
The heck? Huh. Which one is right? Oh my goodness.
So I mean, you and Camila got the same?
Yeah, but we just did it by hand. We didn't use the graph. I don't get what's different about the graph and about doing it by hand. Did you change the degree of freedom, Camilla?
I did. I put 21 for degree of freedom.
Me too. What the heck? is the most frustrating thing in the world.
Yeah.
I don't know, what should we do?
No,
I don't know.
that's dumb. I think I don't know whether to trust the graph or not.
I'm just gonna put the Excel sheet because that's what we got last time too.
Yeah.
Like
Okay.
in that problem, you know, the Excel sheet gave it the same answer as the applet. So just gonna put that one.
Try that. Yeah.
So are we putting Julia's answer?
Well, I'm putting that. If you wanna put the other one,
Yeah, we can try
I
both.
got 0.001.
And we'll see what
What
happens.
is your answer, Julia? Just in case.
My answer is 0.001. What is yours?
0.001.
434.
Ours is 0.434.
Okay. Yeah, we'll see. Okay, so let's go to 11.
Okay.
What decision do? Well, that affects now, right?
Yeah. So Camilla, you and I, we would reject it. I mean, fail to reject, but then Julia would reject it.
Okay. You decide to try another alternative hypothesis. This time you use bigger than 0. And you keep the same level of significance. Did p-value increase or decrease?
I hate that. Okay.
The alternative, but it's higher than no, the 0. Mm. Hmm. So for me,
So we are increasing the
so the alternative hypothesis is that is greater than 0. So in my case, since it's 0.001,
we are decreasing the mean, right? You want me to
oh, I get it. There is a thing here. Because here it says there. So it may change.
Are we decreasing or increasing the mean? I think I guess we're increasing, right? Because it's gonna be bigger than 0.
So in the Excel sheet, as you see here, the type of test, you change it according to what it's asking, you know, less than, not equal to, greater than. So when I change this, my p-value changes to 0.00006.
So it goes down.
So that's decreasing for me, for my
Increase
value.
for us.
Guys,
Yeah.
I think thinking logically, if we increase the mean, so then the p-value will increase too, because the mean is the number dividing. Does make sense? If it was the number being divided for, I don't know how to explain that in English. But
One in the past, like
I see what you mean. I see
one
what you mean.
increase, the other one used to decrease. I'm just gonna go with decrease.
Yeah, I think on Camilla's, on Julie's, dang, I get your names confused because it both ends in
Just because my
Julie's
p-value decreases.
decreases it.
Well, yeah, when it's greater than the hypothesis, my p-value decreases. It was 0.001 and now it decreased to 0.006.
I think that's fine. I mean, I think I think decreasing it would work, but
I think I'll go for increase
Okay.
Yeah, because you're using the other, right? You're not using you're
Yeah.
using your own answer, I guess.
Yeah, then we can compare.
So since it's decrease,
So if the p-value increases,
yes. So I failed to reject because my
we fail to reject, right?
P is
Yeah.
less than the level of significance.
So did you guys put increase too, or you put decrease?
I'll put
I
increase.
put reject the node. Oh, I'm sorry. I put decrease.
Okay, so you put decrease, for you is reject the null. We put fail, sorry, we put increase, so we put fail to reject the null. Oh, I can't wait to finish this thingy.
I know, for real. You know,
Yeah, this one is complicated.
I have this fun little blue thing on the bottom of my screen now.
Math master.
Yeah. Hope it helps.
Okay.
This one kills me, guys. This next one. It's so freaking confusing.
Based on response from the previous question, what combinations do you make? We have to see.
Yeah, this is really flipping confusing. Ah, I might need to use a tutor for this.
11.
Okay, if we fail to reject, so we're sticking with the mean, right? So we have sufficient evidence there. I think it's gonna be or the first or the third.
Okay, let's see. We have. I think it's the third. I think I go with the third one.
Number 3.
Yeah.
Okay.
Yeah.
As we have seen, the p-value depends on the alternative hypothesis. In general, which alternative hypothesis will give the smallest p-value? I think I have a note about it somewhere. I think the second one. Because the first one, we will select 2 fields. The second one, it's left tailed, so we will select just 1 field, which will make our p-value smaller, right?
Yeah, I agree with that. Yeah.
What do you think, Julia?
This depends on alternative hypothesis in general picture. I think because like the last one that I put, when I changed when it was greater than 0, it made my p-value smaller.
Yeah, exactly.
So I think it's 3. I mean 4. 1, 2, 3, 4. 4. So mean D is greater than 0. Because when we use that alternative hypothesis, the p-value was small. So I'm gonna go with 4.
Okay.
Let's see. This is so hard.
It's killing me.
Okay.
Determine the 95% confidence interval for the mean difference between the 2 groups. Using group 1 minus group 2 and putting your answers below. What? Are we using the same tempo? The same?
Yeah.
Like in mine, like that's what it puts the confidence. Just put the 95 here. 95, and it gives you the.
So what'd you get? The confidence?
Doesn't not give you anything. Concrete.
Dude, that's so freaking confusing. Seriously.
So confidence level here is 95, and let me see that. Let me open this one. And then it gives me the confidence interval right here.
We need to calculate
That's-
this score first, right?
What'd you say?
Oh, wait, we calculated this score already.
Yeah. So we need to find the point estimate. So we just need to find a one number that's the
Sorry.
interval.
But like, so we leave it as the last time, you know, we changed it was that the hypothesis was the greater than the alternative. So do we leave it like that? That's our hypothesis, that the alternative hypothesis is greater than the null hypothesis. I don't know if you understand what I'm saying.
How do we figure out the confidence interval? Don't we have to do, so we do the, crap. Okay, so we do 15, don't we do 22, the square root? Here, let me figure it out here.
First point. I forgot how to find point estimate.
So for the point estimate, I got 0.418.
So we're talking about the confidence interval.
Oh, wait, how did you do? Did you do like the t minus the margin of error?
Yes, yeah. So what I did was I did 1.96 times 15.003 divided by the square root of 22. So yeah, the margin of error formula.
So
you find the t-score, then no, you found the margin of error.
Wait, the point estimate isn't just the mean?
No, the point estimator, I think.
No, it's in 1195. I think it's 1195. I remember that one, the point estimator, it was just the same number of the mean.
I think so. I think the point estimator is the mean.
I have 11.955.
955, yeah, that sounds about right to me.
Mommy?
11.9555, okay.
Oh, so the margin of error, I think, then is 0.418. 0.418, I think, because so for that, don't you do 1.96 times 15.003 divided by square root of 22?
How much did you get?
I got 0.418 if I did that.
0.418.
Yeah.
Let me see.
I
How
really,
much did you get, Julia?
I think that the mean is just the point of estimate. 11.
No, the
we're talking
17.
about number 17.
What was that? Oh,
We're doing number 17.
I was. Hold on.
That's okay. My brain is fried right now, so.
So unit 17, what is the margin of error? Okay, let me see margin of error. Oh God, margin value. Is that 21?
One for the
Standard error of the mean, 3.199? No.
I got 0.41A. Is that what you got, Camilla?
Yes.
What is it that you got?
0.418?
0.418.
Yeah.
I'll go with that because I don't see it. It's not. Oh.
Let me do again, just in case.
Sounds good.
All right, so you did 1.98 times 15.003 dividing per square root of 22, right?
Uh-huh. Yeah.
Just one more time. I got 6.27. Okay, I'll do one more time, sorry. I got 6.269.
Okay.
But I think that's wrong.
No.
Okay.
How much did you get, Julia?
I'm trying to find that in the Excel sheet. So give me a second. So t-value. 3.77.
So, what do you guys get?
I got 6.269.
For what? For which number?
For margin of error, 17.
6 point. Sorry, can you say that one time? Sorry.
6.269.
And how'd you get that one more time? Just so I can compare.
Me?
Yeah.
6.269.
No, how'd you figure that out?
So I did square root of, okay, I did 1.96 multiplying 15.003 dividing per square root of 22.
Huh. Let me try that again then.
Is that what you did?
I did that, but I got a different answer. Let me try it again. Um, 0, so then 15.003 divided by 4.69. That times by 1. Okay, yeah, I did get that.
Did you get the same thing?
How much did you get?
6.270.
70. 69. I got 6.269.
Yeah, it's the same.
Okay.
Yep.
At least one. Finally agree on one.
And then for the lower, I got 5.686.
I'm sorry, what?
For the lower bound.
Yep.
And for the upper bound, I got 18.224.
Yep.
5.303, and the other one I got 18.607. Is that what you said?
Yeah. Okay, I'm turning this puppy in.
Okay, our number 4 is wrong. Our number 8 is wrong.
Yep.
Our number 10. Our number 11.
Did you get number 6 right?
12. 6 is right.
What'd you put for number 6?
0.689.
Oh, damn. No. I put 0.669. 0.6689, you said? I think Julia was right on those, on 10, 11, and 12,
Yeah.
13.
Our 17 is wrong. Our 18 and our 19. So, dude, that was horrible. Seriously.
Oh, okay, well, trying to figure the rest out on my own there.
I know, it's so like,
What was wrong in the last
Oh.
ones? Because I keep doing those wrongs. Like the other quizzes, I did wrong too, and I don't know why.
man, everything.
Because I did the way that he taught us to do.
Yeah. Well, anyway, if I figure something out, I'll let you guys know once I figure it out. I can send an email or something because I'm going to spend more time on this because I have no idea.
Is it due tonight?
Yeah, it is. Yeah, I'm going to, after evening up, I'm just going to go and my notes and figure it out.
Dang.
And if I figure it out, I'll email you guys.
Thanks. I'll try to, and I'll let you guys know as
I
well.
had no idea. I was literally just stumbling through that one.
This is
Okay,
the
sounds good.
hardest one so far.
Yeah, I agree.
Okay, I stop the broadcast.